The second type of function that we're going to see in this series of videos about functions is going to be linear functions. And in mathematics, linear functions are always expressed by the following equation. Y equals mx plus b. Now there are different ways to explain this, but I like to do it in my own particular way, as you can see in past videos. M is what we call the slope. And what is the slope? The slope is the degree of how steep the linear function is. As you may have imagined, a linear function is exactly what it sounds. It's a line, a straight line. And the slope is the degree of how steep the line is going to be. Steeper or less steep. Okay? B, on the other hand, is the cut with the y-axis. We're going to get to that in just a second. In essence, M and B belong to the real numbers. That means that they are constants, all right? The only variable that you have in linear function is x, okay? Now let's make a few examples. And let's draw our xy axis. Y and x. The first example that I'm going to go over is what is called the identity function. It's the most basic and simple linear function that you have. It's y equals x. If we do a little bit of a board between values of x and y, it's going to look a little bit like this. If we have x and y, what happens if x is 0? Y is 0. 0 equals 0. What happens if x is 1? 1 equals 1. Y is 1. What happens if x equals 2? 2 equals 2. And so on. Doesn't matter what I put on the x, y is going to be the same thing. So that's why it's called the identity function. It's like a mirror, okay? So when we go to graph this into our xy axis, it's going to look exactly like it might have thought a straight line. Y equals x. Right? As I said in the past video, the domain of the function is the entire real numbers, because this is a function that has no problems at all. Do you see any problems with it? Like any weird division, any weird algorithm or logarithm or sinus or something? No, there isn't. This is a function without any issues. So here we say that the domain of f is the real numbers. And the range, equally, I don't see any issues with the function, right? There's no division, no something weird, no undertermination. It's the real numbers as well. Okay? Got it? Now, let's make a second example. What happens if we have y equals x plus 1? Well, let's do that. Right? Y equals x plus 1. In this case, we have a b now, and b equals 1. This means that the cut at the y-axis is going to be located at 1. We're going to get to that just in a second. What happens if x is 0? Y is 1. 0 plus 1, 1. What happens if x is 1? 1 plus 1, 2. What happens if x is 2? 2 plus 1, 3, and so on. Okay? Now, as you can see, at x equals 0, which means the y-axis, which is right here, the value of x is going to be 1, which is exactly our b. That is where our function cuts. Right here. 1, and when we go graph it, it's going to look exactly like the identity function, but 1 step forward, or 1 step upwards if you want to call it that way. And this is y equals x plus 1. Right? Another example. What happens if we have y equals, x minus 2? In this case, b is negative. Does that mean the function is negative, that there's something negative about the function? No, not at all. It just means that the cut at the y-axis is going to be located at -2. What happens if x is 0? Y is 0 minus 2, minus 2. What happens if x is 1? 1 minus 2, minus 1. What happens if x is 2? 2 minus 2, 0. What happens if x is 3? 3 minus 2, 1, and so on. What will the function look like? It's going to look exactly like the identity function, right? Only that it is placed south 2 spaces. So here we go. 1, or minus 1, and minus 2. This is where the cut is going to be at the y-axis. Minus 2. Everything else is going to be exactly the same. Straight line. Y equals x minus 2. And there you go. These are variations, red and green, of the blue identity function. Y equals x plus 1, 1 space north. Y equals x minus 2, 2 places down. But it's the same. The slope is the same. The identity function is just being displaced up and down. We will get to that more in the second video.